You open the latest specification from a client. It's a dense, sprawling paragraph of business rules filled with overlapping conditions and buried contradictions. If you read through this text and hand it straight to a development team, you will pay for it later. Human language naturally hides logical gaps, and assumptions made during this phase turn into expensive bugs during production. To solve this, we can pull 3 classical engineering tools from our toolkit: the flowchart, the decision table, and the decision tree. By translating a narrative into these specific visual models, we stress test the logic and expose the flaws long before anyone writes a single line of code. Let's look at a practical example: a local print shop. They've provided a paragraph outlining quote rules for regular, silver, and gold customers. The first step is to break this text down into 2 distinct categories. We need to separate the conditions, the events that trigger a rule, from the actions, the specific outcomes the system must execute. Scanning the text, we isolate the exact conditions being tested. A customer is evaluated as either regular, silver, or gold based on their purchase history. Next, we extract the actions tied to those statuses. The system might need to apply an 8% discount, a 15% discount, or physically move the customer ahead in the job queue. Categorizing the raw text clarifies the boundaries of the problem. Developers will know exactly what input to look for and exactly what output to generate without guessing. With our variables isolated, we can map out how the software will evaluate a customer chronologically. This is where a flowchart excels. We start with a selection construct. This diamond shape forces the system to ask a binary question: is the customer gold? If yes, we follow the true pathway. The system applies a 15% discount and dunts the order up the queue. If no, we follow the false pathway down to the next logical test. The system then asks if the customer is silver. As you build this out, keep the flow moving forward. You only want to route an arrow backward if you are dealing with a true repetition construct, like processing a batch of 50 invoices in a loop. Mapping the process this way forces you to dictate a rigid, unbroken sequence of events, ensuring no customer gets trapped in a logical dead end. Flowcharts work well for simple sequences, but they become an unreadable mess of crossing lines when conditions heavily overlap. When the rules get tangled, we use a decision table. In the top left quadrant of this grid, we list every possible condition. Down in the bottom left quadrant, we list the corresponding actions the system can take. The right side acts as a cross-reference matrix. Each vertical column becomes a specific rule, linking a true condition to required actions. This mathematically exposes hidden conflicts, like a logical impossibility, where a customer is flagged as both gold and silver simultaneously. The grid layout forces you to account for every permutation. You can clearly see if a combination is missing, if rules contradict each other, or if redundant actions are triggered. We can also apply this structured approach to high-level project strategy using a decision tree. Let's say management is debating how to implement a new platform. We start with a single root node, the core dilemma, system acquisition. From here, the path splits into our primary options. We can build internally or buy an outsourced solution. Each of those choices creates a cascade of new variables. If we build it, we have to calculate ongoing maintenance. If we buy it, we have to factor in licensing and customization costs. Mapping these divergent paths forces stakeholders to confront the long-term financial consequences of a binary choice before committing any budget. We started with a dense, confusing paragraph of requirements. Now we have a clean, structured blueprint. We use the flowchart to lock down chronological sequences, the decision table to untangle overlapping conditions, and the decision tree to map strategic choices. Handing these documents to a development team removes the guesswork. Engineers aren't left trying to interpret human nuance or making assumptions to fill in the gaps. Quality software engineering requires taking the messy reality of human requirements and forcing them into a disciplined visual structure before the build begins.